Hello everyone, we are from group 10. We'll be presenting about our project which is health monitoring system. So the introduction about the health monitoring system is about the system have increasingly become important for various health conditions. Besides that, the monitoring and managing various health conditions requires continuous monitoring which includes heart rate, blood pressure and physical activity levels. So one of the main problem that many individuals neglect is their health and does not prioritize their regular health monitoring, which results some health condition that can go unnoticed or only be detected at the advanced stage. Furthermore, traditional methods of health monitoring system are often limited in cost or in scope and does not provide comprehensive monitoring of an individual's health. Next, the lack of comprehensive health monitoring can lead to increased healthcare costs. So the objective of this project is to design and develop a health monitoring system using a FreeRTOS with Arduino IDE. Next, we have to evaluate the accuracy and reliability of the health monitoring system in measuring heart rate, blood pressure and the temperature. So here is the block diagram of the health monitoring system, which has 3 inputs and 6 outputs. The inputs are the heart rate sensor, temperature sensor and the pressure sensor, while the Arduino Mega acts as a execution component for the output. The outputs are the heart rate, temperature, blood pressure, LED, buzzer and LCD. So the material and equipments that we use for this project are the temperature sensor, pulse rate sensor, heart rate sensor, accelerometer, LED and buzzer. And the software we use for this project is the FreeRTOS A and Arduino IDE.
Assalamualaikum and good evening. This is for flowchart. First, we have initial monitor parameter task. This task will monitor the input from the heartbeat sensor and blood pressure sensor. When the abnormal happen, such as let's say heartbeat value is more than the normal value, so the yellow LED will turn on in the yellow control task, and the buzzer will synchronously turn on. For the blood pressure, when the value of blood pressure is abnormal, the red LED will turn on in the red control task, and also the buzzer will also turn on. If when the doctor came to the patient and turn on the buzzer will also turn on. The function of buzzer is just to give the notification to the nurse or doctor about the condition of the patient. So if there is no abnormal value to the patient, the LED for yellow and red will turn off and buzzer also will turn off. This LED yellow and red can turn on simultaneously if the heartbeat and blood pressure is abnormal. Next, this is the code. First, we initiate everything input, initiate every variable, also the normal task handle, also the task handle. So as you can see, we get a variable for LED yellow. This is a number for the pin at the Arduino board. So for LED yellow, the control pin is at 13, LED red at 12, buzzer at 11. For heartbeat sensor pin, blood pressure sensor pin, and temperature sensor pin. This is for the input. So the pin is 2, 3, and 4. And then we initiate also the value, the variable for the button state HP, button state BP, and button state T. This to use in other task. So yeah, so we set the threshold, the blood pressure threshold. This is if this is the normal value for the human, and if uh, the value of the sensor is not in the value, so it will indicate as a abnormal. Next, this is a setup function. So we initiate input output for the pin that in the previous, and then we also initiate we also task create in here. All we have 4 task create: normal, monitor parameter task, on yellow task, on red task. Next, this is the loop function. So the loop function, we just print the loop function. Next, this is the void monitor parameter task function. So this code will all run continuously, whether whether it's on task, another task. So like such as turn on the LED task, turn on red task, turn on red task. So this is the for the monitor parameter task function, and this is for the normal function. So we can see that we set the high priority is the yellow control task and red control task. While for the monitor parameter task, we put the lowest 2, and normal task for the lower than these 2, yellow control task and red control task. So this high priority because if the condition of the patient is abnormal, so this task will be take action. So it will print abnormal status in the LCD display, and it will print the value of the input. So for the normal task, it just give the display the normal value. Okay, that's all for me. Thank you.
My name is Jajan. So now I will show the simulation of this project. So this is the schematic diagram of our project. In here we have heartbeat sensor, Arduino Mega. In this project we have 3 inputs and 3 outputs. The LCD was included here for us to see the clearer picture of the result. So after we simulate the code and we get the Arduino hex file into this simulation software FreeRTOS 8 inside the Arduino Mega. So we start simulate. So at first, the user able to see the heartbeat sensor, pounding, the BPM, the blood pressure, and the temperature at the right of the LCD. So at here we successfully make the simulation of the heart pounding in here. So we cannot make the analog reading from the heartbeat sensor. So we replace it with the input switch here. This switch activates means the heartbeat pressure, heartbeat sensor, or the blood pressure or the temperature was out of the threshold. So once it's reached the threshold, it will activate the LED respectively. So the switch was on, which means the heart pound is higher. So the LED yellow was light up, and the buzzer will go off and call for some doctor to some diagnostics. So same as the other sensors. So the buzzer still go off if the LED red is light light on, the BPM will the parameter was higher. The over limit exceed the threshold. If the both is exceed the threshold, they will both light up. So once the doctor came to the patient, this switch can let the doctor do an option to close the buzzer off. So it's off. So at the LCD, we can still see the abnormal here. It still shows the real time of the patient parameters. Once doctor diagnoses the patient and the parameter remain to normal, so when this indicator switch was connect to high value, then at here the program will show this is normal for the patient. So it will remain silent and the buzzer won't turn on. So this program will keep looping and keep checking the status of the patient. So now we have the Arduino board for physical simulation. We reset the Arduino Mega first. So now the program keep looping. From here we can see the patient status is normal and keep monitoring. Now we assume the sensor sense the patient is not in good status, such as BPM is over a threshold. So the buzzer will light up and the yellow LED will light up. If the patient return to normal parameter, the buzzer will stop and the LED will turn off. So now we can see from the prompt, the yellow LED will light up and keep monitoring. So now it's normal. Now for the second LED, for the another sensor, once it exceeds the threshold, it's not in good status, the buzzer will turn on and the LED, the red LED will turn on. In here represent the green LED into the red LED. So now we assume the sensor sense the patient parameter is abnormal, so both LED lights up and the buzzer light up, as shown on the serial prompt. So if the doctor want to turn off the buzzer, he can turn off the switch as shown in the video. So in this moment, the program will still running the red LED task and the yellow LED task and keep monitoring. So if the parameter become the normal, it will show the normal again. So that's all from the simulation. The possible improvement that we can think is we can adjust the stack size for each task based on each requirement. The extra stack usage of each task was evaluated and adjust to the minimum accordingly to avoid wasting of memory. So the next improvement we can see is the task priority was analyzed and rearranged to ensure that the higher priority tasks get sufficient CPU time. This will prevent the lower priority tasks from blocking critical tasks. And the last improvement we can think is the longer delay period in tasks that we don't require the frequent updates. This will increasing the delay period to reduce the CPU load. In conclusion, a health monitoring system is able to be built that able to monitor the heart rate beat per minute, blood pressure level, and the temperature of the patient. This health monitoring system provides individuals with the tools and the resources to monitor their health and manage chronic health conditions in a convenient and a cost-effective manner. That's all from us. Thank you.